Alright, the chain rule when we want to take the derivative of composites, and we worked on that for a few days, so hopefully you are up to par on that. Our quiz that we should have had yesterday, 3.5, 3.6, we're going to have on tomorrow. Okay, so 3.5 on trig functions, derivatives of trig functions, 3.6 chain rule will be tomorrow, okay, that quiz. Today we want to talk about implicit differentiation. Implicit differentiation. Right now we've been taking a derivative and it's always been solved for y. But what if it's not solved for y, that we have something more than just y? And we want to be able to do the implicit differentiation, but we still want to get dy dx. dy over dx is my derivative rule. Alright, the function, the derivative of y in respects to x, dy over dx. So take for instance, you get x cubed plus y cubed equals 18xy. Our rules do not change. Our rules are still the same as far as derivative is concerned. We have a function, and we have a product of a function. So we're going to take the derivative, and we're going to use the product rule for the function. So what we're going to do here, though, when we have multiple variables involved, we're always going to do, anytime we take the derivative in respects of a function or to a variable, we're always going to write dy, dx, dv, dw, whatever the variable is in that function. So when I take a derivative of x cubed, it's going to be 3x squared dx. So I took the derivative in respects to x. When I take the derivative of y cubed, that's going to be 3y squared dy equals, the 18xy is a product. So we're going to use the product rule. The first, 18x, times the derivative of the second, which is 1, so it would be dy, plus the second, which is y, times the derivative of the first, which is 18 dx. So whenever I take a derivative of a term with a particular variable, I'm always going to write d, whatever that variable is, afterwards. Again, my goal is to get dy over dx. So when I simplify this out here, I got 3x squared dx plus 3y squared dy equals 18x dy plus 18y dx. I'm going to do just like when I solved equations with multiple variables. I'm going to get the same term on the same side. So I want to get all my dx's on one side, all my dy's on the other side. So I bring my dy's to the left. And my dx's, to the right. Then I'm going to factor out my dy's. And factor out my dx's. Again, my goal is to get dy over dx. So I want to get the dx over here. How do I do that? By dividing. And take this over to the right, because I don't want it with a dy. And I notice I have 18y minus 3x squared over 3y squared minus 18. Now I can see that I can factor out a 3 out of both those terms. And there's my derivative.
When you took the derivative on the right side.
Mm-hmm.
Why is it 18x? Why is it dy?
Then I'm gonna take the derivative of the second term, which the second term is y. Derivative of y is 1. And what did I take the derivative of?
The first time or the second time?
That time right there.
Why?
Y. So I always put a dy. Whatever I took the derivative of, I'm always gonna have a d whatever. So if I took the derivative of something that had a w, then it would be dw. If I took something that had an a, then it would be dA. Alright, so anytime I take a derivative that has a variable, then it's always going to be d whatever that variable is. So here, I take the derivative of y, so it's dy. Here, I ended up taking the derivative of 18x, so therefore it's dx.
Okay.
Okay, so whatever I take the derivative of, that's what I'm going to have. Let's look at another one. You get another marker.
Oh, that's good.
This is called implicit differentiation.
Differentiation? Is that what you said?
Yep, implicit differentiation. Alright, which is taking a derivative implicitly. Alright, let's look at another one. X plus sine y. So I want to find the derivative of this function, dy over dx. So I'm going to take the derivative. Derivative of x is 1 dx. So I took it with respect to x. Derivative of sine y is cosine y, and the variable was y, so it's dy equals product x times y, so 1 d2 plus 2 d1. So anytime it comes down to 1 or a number, it's always going to be that dx or dy. My goal is to get my dy's together, so I'll bring those to the left. And my dx is to the other side. I'm going to factor out my dy's and my dx's. And I'm going to make it dy over dx. So I'm going to get the dx over here by dividing by dx. So I'm going to take this over here by dividing by that. And there's my derivative. Why can't I find a marker that works?
It's dy over dx equals.
Dy over dx equals, yes. There we go.
So then shouldn't cosine minus x be on top?
No, because I'm taking this over here, and I'm taking this over here. So to get it from this side to that side, I gotta divide by it. And to get this from this side to that side, I gotta divide by it.
Okay.
Let's look at another one. Alright, so here we got x sine 2y equals y cosine 2x. And yeah, I got everything in there. I want to find the slope of the line, of the curve at that point. To find the slope, I gotta do what?
Find the derivative.
Take the derivative. Alright, if you notice, I got a product and a composition. I got x times sine 2y, and this is a composition, this is a function within a function. Alright, so I'm going to use the chain rule, I'm going to use my product rule together to do that. So again, here, it's going to be the first times the derivative of the second. Derivative of my composition is the derivative of the function times the derivative of the composite. What's my function? Sine. Okay, what's the derivative of sine? Cosine 2y times the derivative of my composite. What's my composite? 2y, what's the derivative of that is? 2. So there's the first times the derivative of the second, plus the second. Oops, you know what I forgot? Forgot my dy. Plus the second times the derivative of the first. Derivative of the first is? 1. In respect to x, so it's dx. Equals, again, product rule here, first times the derivative of the second. Again, a composite. What's my function? Cosine 2x, so the derivative of that is?
Negative 2x.
Negative sine 2x, right? Times the derivative of my composite, which would be 2. And again, that's dx. Plus the second, cosine 2x, times the derivative of my first, which is
1.
dy. So let's simplify this up some. This is going to be 2x cosine 2y dy plus sine 2y dx equals negative 2y sine 2x dx plus cosine 2x dy. Get my dy's on the same side. 2x cosine 2y dy minus cosine 2x dy equals negative 2y sine 2x dx minus sine 2y dx. Factor out my dy's and dx's. dy times 2x cosine 2y minus cosine 2x would be dx times negative 2y sine 2x minus sine 2y. Take dx over here by dividing. Take this over there by dividing. So it's negative 2y sine 2x minus sine 2y all over 2x cosine 2y minus cosine 2x. So there's my derivative. How do I find my slope? Put my x and y of the point that it passes through, my tangent line, which they say is pi over 4 and pi over 2. So I just plug those in. Negative 2 times pi over 2 sine of 2 times pi over 4 minus sine of 2 times pi over 2 all over 2 times pi over 4 cosine of 2 times pi over 2 minus cosine of 2 times pi over 4. Negative negative 2 times pi over 2.
Negative 1. Oh wait, I mean negative 5.
Negative pi. Sine of pi over 2. It's 2 times pi over 4 is pi over 2. Sine of pi over 2.
Oh, that was, yeah.
1. Sine of pi.
0.
2 times pi over 4
Pi over 2.
times cosine of pi
1.
Negative 1.
Yeah, you're right. Okay, thank you.
minus cosine of pi over 2.
Plus 1. I mean it's
Negative 1, but, yeah.
Cosine of pi over 2 would be 0.
Shouldn't it be minus cosine 2x? So, oh, wait a minute.
Oh, yeah, we said that, right.
Never mind.
Yeah,
Never mind. Wait,
Right. Am I good?
so then, wait, so negative 2y
because it's pi over 2 is
sine, I think I screwed something up, hold on.
1 0 0 or 1 0 and 5.
2x.
Am I good?
Okay, yeah, you're good, that is
Yeah.
my fault.
Mm-hmm.
Okay. Which equals negative pi over negative pi over 2, which equals,
2. Nope.
yes,
Yes.
2. So they're asking us to find the tangent and the normal lines. So if my slope is 2, going through this point, y minus pi over 4, I'm sorry, pi over 2 equals 2 times x minus pi over 4. So we have y minus pi over 2 equals 2x minus pi over 2, so y equals 2x is my tangent line. Everybody with me?
Mm-hmm.
Well,
Normal line. My normal line, what's the relationship with my slope and my tangent line?
opposite.
So I got y minus pi over 2 equals negative 1/2 times x minus pi over 4. Y minus pi over 2 equals negative 1/2 x plus pi over 8. So y equals negative 1/2 x. Take pi over 2 over it, take it over as 4 pi over 8. So it'll be 5 pi over 8. So normal and tangent. Using implicit differentiation.
That's a lot of math.
It is a lot of math.
It looks really bad,
But it's
but
fine.
really when you think about it, it's not that bad.
It's not terrible.
Yeah, it's not
No.
terrible, that's good. It's not definitely.
But it is tedious, so if you don't stay neat, if you don't stay spread out, if you try to crunch it all in on a small piece of paper, you're going to make mistakes. But you have to stay neat. Try not to skip too many steps. Because when you start skipping steps, you are going to make mistakes. Let's look at another one. Going through 0 pi. Again, I'm looking for the normal and the normal and tangent lines, so I gotta find the, what do I have to find?
Derivative.
Derivative, because I'm going to find what, Hunter? To find the normal and tangent line? What do I need to find?
The slope,
Slope. How do I find slope?
the derivative.
Derivative. So write this example down. Product. First. Times the derivative of the second. I have a composite. my function is,
Oh, sorry, cosine,
not right here, what's my function?
u squared.
U squared, and my u equals cosine y. So when I take the derivative of this, dy over du equals 2u, and u equals du over dy
Y.
here would be
It's negative sine. Y.
negative sine y. What am I gonna do with those?
Multiply.
Multiply them, so it's negative 2 cosine y sine y dy. Would everybody agree?
No. Oh, wait, no, I forgot to plug in the u, never mind.
Yes?
Well, wouldn't
So first times the derivative of the second, which would be negative 2 cosine y sine y dy, plus the second cosine squared y times the derivative of the first, which is 2x dx, minus the derivative of sine y is cosine y dy equals 0.
back to when we multiplied the composition,
Uh-huh.
dy over du times du over dy, wouldn't that be 1?
Yeah, but because I have a y here, I probably should have put this as something else. Let's go, z,
Okay.
in the function something else, saying it was in terms of y. Yeah. So simplify, negative 2x squared cosine y sine y dy plus 2x cosine squared y dx minus cosine y dy equals 0. I'm gonna get all my dy's on the same side, so negative 2x squared cosine y sine y dy minus cosine y dy equals negative 2x cosine squared y dx. Factor out my dy. And then I got my dx. Bring my dx over, that's dy over dx equals negative 2x cosine squared y over negative 2x squared cosine y sine y minus cosine y. And there is my derivative.
Can you factor out a cosine y? Or, that's an x. Wait. No, we can.
Correct? Alright, so we can actually factor out a negative cosine y.
Alright.
So that would be 2x over 2x squared sine y minus 1. Oh, it should be a cosine y on top. We want to find it through 0 pi, so it's going to be 2 times 0 cosine pi over 2 times 0 squared sine of pi minus 1. Well, 2 times 0 is 0 times cosine pi is 0 over minus 1, which is
Negative 1. No, negative 1. There. What? Sorry.
0, right?
Yeah.
Tangent line. The slope is 0. That means it's what type of line?
Or it's vertical.
You're right the first time?
Oh, not the tangent line is horizontal.
Horizontal. Horizontal line, how we write it? Y
Y
equals, what's y equal?
0.
Pi.
Oh, yeah, sorry.
Normal line, if it's normal to the tangent line, it's going to be
Vertical.
vertical. How do I write a vertical line?
X equals
X equals, and what does x equal?
0.
Y equals 0, x equals 0. Alright, so tonight what I want you to do, I want you to do page 162, numbers 1 through 25, every other odd.
Wow.
Alright? 1 through 25, every other odd. Implicit differentiation. Okay?
Page 162, 1 through 25, every other odd.
Yes.